Hello, everybody. So my name is Chamikara Jayalath. I'm a committer and a PMC of Apache Beam for some time, and I'm also a software engineer at Google. So today I'll be talking about managed transforms, which gives you the power of Beam transforms, but without the maintenance overheads that comes with Beam SDKs. All right, so let's first talk about what Beam transforms are. So Beam transforms are computation units that you can apply on your data. Right. And these can be applied in parallel. So Beam runners are very good at taking these transforms, and they can run these in parallel on your input data, which is in the form of Beam P collections on across, say, thousands of nodes. Also, Beam transforms are composable, meaning that you can take transforms, put them together, and build more composite transforms, and keep doing that. Beam transforms are executed in well-defined environments. For example, an environment could be a Docker container that has your Beam SDK installed in it. All right, so here are some of the examples for Beam transforms. Beam comes with a number of core transforms, things like Padu, Combine, Flatten. Pretty much all I/O connectors you find in Beam are transforms. So if you take text I/O read-write, Iceberg read-write, Kafka read-write, these are all Beam transforms. Beam comes with a number of utility transforms. These are things like sum, top, count, and many more. There are turnkey transforms. These are transforms that give you a specific functionality that you can customize to your needs. So things like run inference, ML transform, enrichment, anomaly detection. These are turnkey transforms in Beam. Beam also has a concept called multi-language transforms, also known as cross-language transforms. These are transforms actually implemented in other languages, others SDKs that are available to a certain SDK. So for example, if you use Kafka read and write from Python, they are multi-language transforms because the actual implementation is in Java. And if you use run inference from Java, that's again a multi-language transform because the actual implementation is in Python. All right, so there are some downsides to transforms. One downside is that the transform API, the way you construct your transform object, can vary widely. This is, for example, makes it hard to move from one I/O connector to another. Usually, say you are very familiar with BigQuery or some transform, then you want to use something else. Like Kafka, you have to go and kind of relearn the API to construct that new transform. Also, moving from one to another involves a number of things. If you want to modify your pipeline, these transforms take different input types. Sometimes, these are the input element type of the P collection coming in. So if you are, using a sink, you have a incoming P collection. That type might be different, so you might have to modify that. If you are changing your source, again, the element type it produces might be different. You will have to change that. Also, the configuration of the transform itself, the constructor, could vary widely. They might use like language-specific types. So that, again, can be a difficulty, right? This kind of makes it hard for runners to, Beam runners to reconfigure these transforms internally, because they might take like very language-specific constructors, right? Language-specific objects. So for example, if you have a Java transform that takes certain Java objects, a runner implemented in C++ might not be able to reconstruct that transform. All right, so to overcome with these limitations, we came up with something called schema-aware transforms. This improves the API in a couple of ways. Now, first, it uses standard input and output types. So all the incoming and outgoing P collections will be of type P collection of type raw. Raw is a schema'd standard element type in Beam that's also language portable. Also, to construct the transform, now we give a raw object, a raw that will have your, the constructor parameters in its schema. And that is, again, standard and language portable. If you have existing transforms, that can be relatively easily converted to a schema-aware transform by implementing two interfaces. One is called schema transform provider. The second one is called schema transform, so you can convert existing ones. And underneath, it'll be the same transform. So if you have a very stable connector, you can create a schema transform, schema-aware transform that will still use the battle-hardened code from that connector. So what is managed transforms? So managed transforms is a new API that we introduced to Beam that encapsulates a number of schema-aware transforms. We currently primarily focus on I/O connectors, sources and sinks, but in the future, this can be generalized to support other transforms. Managed transforms offer and standard API to construct them. Since again this is built based on schema-aware transforms, it's a pretty standard the way you construct different transforms. Also, they offer a standard API to use them because they produce the same input-output types. Managed transforms are multi-language compatible. They are currently primarily implemented in Java, but you can use this from Python via the multi-language framework. All right, so let's look at some the high-level API. So if you use Java, and if you use the managed API in Java, this is how you would construct a source or a sink. So at the top, you would, that's how you would create a source. At the bottom, that's how you would create a sink. So you would just say manage.read and give the key. The key would identify the exact source that you create. And you would say with config and give a set of configurations that are used to construct that source. And this source will produce elements of, now this will instantiate your transform, and when you apply it to a pipeline, it will create a P collection of type raw, one or more P collections. Similarly for sinks, it will consume one or more P collections of type raw, and you would construct it using manage.write, the key that identifies the sink, and with config, the configuration to construct it. Now, if you move to Python, again, very similar. There's a module called manage in Python. Just use that. And to construct a source, say manage.read, the source key to construct identify the transform, the config as a Python dictionary, produce P collection of type raw, for the sink, manage.write, etc. Okay, let's look at some specific examples. If you want to create a Java BigQuery I/O source using the managed API, you would first construct your config map, which has now BigQuery specific configs. For example, you might need a query for the BigQuery source, and you would say manage.read, and your key would be manage.bigquery, and you give it your construct config, and you have your BigQuery source connector. If you want to create a Kafka source, now you create a config with slightly different things. You would need a Bootstrap servers for your Kafka cluster. You would need a topic, for example. But the rest is very similar. Manage.read. Now the key is manage.kafka, and and your config. You don't necessarily have to give a dynamic dictionary. You can also create your config as a YAML file and store it either locally or GCS, and just give that stored YAML file to construct your transform. And to do this, you would, instead of calling with config, you would call with config URL and give it the path to your config file. If you want to create a Python iceberg source, very similar, you would create a config Python dictionary. You would have your iceberg table, for example, and manage.read, managed iceberg, and your dictionary, right? So I hope this gives you an idea how consistent these APIs are, and it's easy to move from one to the other. Other important thing I want to point out is that these are not new connectors. These are all the same stable, same connectors that you use in the other API, but now exposed through a more consistent standard API. All right. So one of the difficulties here is that, as I mentioned, you have to give your config. And the set of configs that you specify for each connector could be slightly different. So you have to know exactly what fields I can give for each connector. So to make this easier, what we did was we created a website that is auto-generated via tooling. So it goes to our code, and we dynamically generate this website at certain intervals. And here you will find the latest set of configs you can give for each source and sink. So it is easy to find out if you want Kafka, right? These are the things I can specify in my managed transform, and it gives other details like a description, type, etc. All right. So far I talked about the API side benefits of managed transforms. But there are also a number of things we can do at the runner side. Now, since these managed transforms has a standard raw connector that is language neutral, runners can, reconfigure these transforms at runtime using this standard connector. They can recreate these transforms, for example, using newer Beam versions of that has fixes, and plug them into the rest of the pipeline, and thus upgrading that transform dynamically. We guarantee that managed transforms are upgrade compatible, meaning that you can take the constructor from an older Beam version and use that to create the same transform in a newer Beam version. Also for streaming, this is specifically for Dataflow, we guarantee that these transforms are update compatible for streaming, meaning that Dataflow has the concept of updating your pipeline. You can just keep the running pipeline and keep updating instead of relaunching it. We guarantee that these will be compatible when you update. And these runner side benefits are only available to Dataflow today, but the managed transform themselves work for any runner. So you can create a managed transform and run them using any Beam runner, no problem. But these things like upgrading are like runner Dataflow specific features today. Okay, so let's talk a little bit more about the Dataflow side implementation. So what you do is, so assume you submit a Beam pipeline using SDK version 2x0. And this has some standard I/O connectors as well as managed Iceberg source. Now, when the Dataflow service receives this, what we do is we construct a managed Iceberg source using a newer version here to Y0. And when you run these pipelines in GCE VMs, we will be starting two containers now, two Beam SDK harness containers, one for 2x0 and 2 for 2y0. Your Iceberg will run in the more recent 2y0 container, while the rest will run in 2x0 container. So as I mentioned, what Dataflow does here is automatically upgrading your managed transforms to a latest Beam version. So this is important because upgrading Beam is not always easy, and we release Beam every 6 weeks. So for some users, it's a lot of work to go and run the whole workflow, all the testing to keep upgrading Beam. And sometimes you don't want to upgrade all of Beam. You just need this one connector you care about and keep it up to date, right? So what this does for you is you can just stay in the same Beam version or upgrade less regularly. We will make sure that within the service, we always upgrade it to the latest version. So when we upgrade, we don't just upgrade the transform, we upgrade all the dependencies that are needed by the newer version, right? So this means that if there's a vulnerability fix or a new critical bug fix, all that will be given to you via the service. Currently, upgrading is done in two different places. When you submit your job, we always upgrade managed transforms to the latest supporters version. And if you use Dataflow streaming jobs, if you do update request, we again, upgrade these transforms. Even if you do the upgrade within the same Beam version, we upgrade them to the latest supported version. Okay, so another thing Dataflow does is it tries to reconfigure some of your managed transforms to better suit the rest of the pipeline. A good example here is the BigQuery I/O sync. So BigQuery I/O sync in storage write API mode has two different delivery semantics. There's the at least once delivery semantics, and there's the exactly once delivery semantic. Dataflow also, the Dataflow runner has two different streaming modes. There's at least once mode and the exactly once mode, right? So if you have your Dataflow pipeline already in at least once mode, it doesn't make much sense to have your BigQuery connector in exactly once mode because you already have the rest of the pipeline is at least once guaranteed, right? So what we do is we go and dynamically reconfigure this transform to use the at least once mode. This is beneficial because in that mode, your connector will be less expensive, and it'll result in lower latencies. So the overall benefit, as I mentioned, is that you can stay in the same Beam version and focus on updating your pipeline itself, have the correct business logic, and don't worry about having to upgrade Beam every 6 weeks or so, or do it less regularly. We will make sure that these managed transforms are always up to date when you submit your jobs or when you update your jobs. Okay, so we ran some performance benchmarks to see how these upgraded jobs perform on Dataflow in some real-world scenarios. So first benchmark here is a pipeline that read from GCS and wrote data using the managed Iceberg sync, which was backed by a Hadoop catalog deployed in GCS. This pipeline was submitted using an older Beam version 2.6.0, and the service automatically upgraded the Iceberg sync to the latest supported version. This was run using 100 N1 standard 4 VMs, and the data size went from 1 gig to 100 gigs here. So what we noticed, and we looked at two things. We looked at the total compute usage as well as the total end-to-end execution time of the pipeline. And we noticed that it's pretty linear with the data size, which is what we wanted to see. We also ran a streaming pipeline. This here, we read data from Google PubSub, and we wrote using the managed Kafka sync. And this pipeline uses, at steady state, it used 10 N1 standard 4 VMs. The max was set to 20. And we ran it for a few hours. And it was pretty, as you can see, it was pretty stable. And throughput was pretty good, about 250K messages per second. So that is our streaming pipeline. And the latency was pretty low, 1 second or less. There was some backlog initially in the Kafka class, when we read from PubSub, and that was cleared during the execution of the pipeline. Yeah, so here are some resources. The first one is the auto-generated configs. So if you want to use managed, if you're not sure what config to use, go to that one, and it'll have the configs you need. The second one is more about how Dataflow support and Dataflow specific features. The last two are the Java and Python APIs for using managed transforms. Yeah, thank you very much.